you very much, and welcome to everyone on the line. My name is Madeline Malmgren, and I'm a Business Intelligence and Analytics Consultant with Thorogood Associates. I'll be joined today by my colleague Claire Barks, who will be running some of our demos. We both work as part of the Tableau practice at Thorogood. Thorogood is a specialist consultancy for business intelligence and analytics. We help our customers match their business goals with technical possibilities. We operate as a single, integrated organisation across our locations in London, New York, Philadelphia and Bangalore, and we provide a full range of BI services, from strategy to design and implementation to support and training. We have also highlighted a few of our vendor partnerships relevant to today's material. Of particular interest to this webcast among these partners is Revolution Analytics, which scales the use of R to an enterprise level. Revolution Analytics was recently acquired by Microsoft, another one of our partners. For a complete listing of our partners, you can visit our website. The focus of today's presentation is integration with Tableau, and there are three key topics that we will cover. Firstly, we will present Tableau's ability to connect big data technologies, such as Hadoop, to enable big data exploration. We will also feature Tableau's data blending capability in this section. Secondly, we will demonstrate how you can leverage the statistical language R for advanced analytics, such as clustering, and present these results in Tableau. And lastly, we will show how you can embed your Tableau server dashboards into your web portals, such as Microsoft SharePoint, for a custom user experience. We appreciate that everyone on the line will have a different level of experience with these topics, so we will provide a brief introduction at the start of each section for context. So let's start off with an overview of Tableau and its products. Tableau's mission statement is to help people see and understand their data. Their products accomplish this with a powerful combination of ease, speed, and flexibility suitable for any audience that wants to analyze data. Tableau is fantastic for intuitive data exploration and impactful presentation through visualization. We hope to give you a sense of these characteristics and where they may fit into your organization throughout today's demonstration. There are several products in the Tableau suite. Tableau Desktop is installed on your local machine for individual use. With Desktop, you can connect to data sources, explore data, and author dashboards. This is where you create content. There is also Tableau Server, which is a web-based platform for collaboration and sharing. This is accessed via your web browser or mobile device, and is where you publish content. As the illustration shows, you would create content in Tableau Desktop and publish this to Tableau Server to share with your colleagues. Tableau Reader is a desktop application which allows you to open and view visualizations created in Tableau Desktop offline and without access to Tableau Server. Tableau Public is a free data visualization tool to help you create interactive visualizations to share or embed in your website. And finally, Tableau Online is a cloud-based source for data analysis. We will feature two of these products in our presentation today, Tableau Desktop and Tableau Server. So now let's go on to our first section, leveraging big data with Tableau and Hadoop. Hadoop is a big data platform designed to process massive amounts of data in parallel. Big data is a generalized term for any collection of data sets so large or complex that it becomes difficult to process them using traditional data processing applications. Hadoop in particular originated from a need at Google to handle their data explosion more effectively, a challenge that most enterprise organizations will face today. Some of the characteristics that define Hadoop are low-cost data storage, a high degree of scalability, the ability to store structured, semi-structured, and unstructured data, as well as batch-oriented query processing. With that backdrop, let's simply consider Hadoop to be another data repository in your organization, which you can access via Tableau. You may already connect to Excel files, relational databases, or OLAP databases, and like these, Hadoop is another source of data for analysis. Tableau's use of visualization easily reveals patterns and outliers while exploring large or complex data which we would store in Hadoop. In addition, Tableau's data blending capability allows you to integrate your big data with other data sources, such as your data warehouse. Most importantly, the use of Tableau on top of Hadoop bypasses the need for technical skills to write SQL, structured query language, or HQL, Hibernate query language, to retrieve data from Hadoop. Any business user can explore this data through the drag-and-drop functionality of Tableau. Also, in light of the data explosion, there are constantly new data sources popping up, and the combination of Hadoop and Tableau can help you demonstrate the value of a new solution in a cost-effective way. Now let's consider a common scenario on data archiving. There is a general reluctance or even fear for archiving data on tape, as your data is now offline, inaccessible, and even slow to restore when it is needed. However, by refusing to archive data, this places added strain on the data warehouse and the data you access most frequently. As a solution, Hadoop can be leveraged as an active data archive. We can identify our hot and cold data based on usage and change, and ultimately migrate our cold data onto Hadoop. This is cost-effective, it eliminates the strain cold data can place on your data warehouse, and most importantly, your cold data is still at your fingertips as opposed to being offline, thus the active archive. So in this case, we'll use Tableau to quickly access both our hot and cold data. Further to that, we'll use Tableau's data blending capability to integrate these individual data sets into one single analysis. So to do this, I'm now going to switch over to Tableau Desktop. Now, as I mentioned earlier, in our product overview, this is where we can connect to data and create visualizations. In the top left-hand corner of my screen now, you'll be able to see three data sets. Firstly, we have our data warehouse, which is stored in SQL Server. We then have our data archive, which we're storing in Hadoop. And then we have an Excel file, which I will come back to later. In the following scenario, I'm putting myself in the role of a business analyst exploring my enterprise data warehouse. So for example, I may want to see my product categories and how they are performing in terms of sales amount. So as you can see, in 2 clicks, I've been able to create a simple bar chart very easily. I may now want to filter down to only show the year 2014. So let's just add that quick filter to the page and drag the slider up to 2014. And again, very quickly, we are able to filter down the data. I may then want to compare this data to a year from the archive. So I'm going to click on my secondary connection. Now here in our secondary connection, we can see the same list of fields as we had in the data warehouse connection. However, we also see some grey links to the right. These links represent the fact that blending is available between the 2 connections. Tableau has recognized that we have the same data types and field names in both connections. This ability to blend means we can show data from both connections within the same visualizations. For blending to be possible, it is key that the data structures in each of these connections is well aligned. This is a situation in which it could be helpful to talk to a company like Thorogood to design these data structures so that your archive and data warehouse can be blended as seamlessly as possible. On the product category field, we can see an orange link, and this is because product category is currently being used in our visualization. So the blend has automatically been activated. So what I'm going to do now is filter down to 2009 within my archive. So let's add that quick filter to the page as well. And again, I can use a slider, but we also have the ability to type in those numbers as well. So I'll do that for the top level of my filter, 2009. So you'll see that it's taking a couple of seconds to query this data. We actually have 100 million rows in our Hadoop connection. So given the data volumes, we're actually getting very, very fast performance here. So now that I've filtered that down to 2009, our data warehouse data hasn't actually filtered because we haven't filtered that particular connection. However, if I now pull on my sales amount from my archive, Tableau is going to create 2 separate bar charts representing each of the connections. But as I said before, we're blending on product category. Here, it's very difficult to tell the difference between the numbers in each of these categories, so comparing 2009 to 2014. So in this situation, I'm going to use Tableau's Show Me feature. Now this feature allows Tableau to recognise the different dimensions and measures we are using in our visualisation, and it will suggest different chart types which would be suitable for the data we're looking at. So I'm going to choose a side-by-side bar chart. So now if we go back to the example of the hot and cold data, we've got the red, which is our hot data in our data warehouse, and the cold data from our data archive, shown in the same visualisation. You may have noticed that we now have 2 date filters for this visualisation. This isn't particularly intuitive, and for the end users may be quite confusing. So these 2 filters over here. So ideally, we'd like to have these 2 filters as one. And that's what we'll do on our next example. So I'll go to a new sheet. Here we're going to use our Excel connection. So this is a simple Excel file which we have created, which contains all of the years within our data warehouse and our archive, and also the product categories. And all we're going to do is use this to blend together the 2 connections, but more seamlessly than we had before. Just to show the segmentation between those years, I'm going to show you the calendar year from Excel. So we've got that full range, 1992 to 2014. If I then show alongside Hadoop, we're going to have all of those years up until 2011. Just wait for that to load. And then if I bring in my data warehouse years, we'll have 2012 to 2014. So that just shows how the data is split between those 2 connections. If I now want to create the same visualization as I had before, let's drag on product category from my Excel file, and I'm going to switch those rows and columns. Let's show all of that data. We've got a lot of columns now showing, so I'm going to filter that down, again using my Excel file. Let's add a quick filter. Now we have a full list of years for our quick filter, and I'm going to bring in a few years from our archive and a couple of years from our data warehouse. Let's expand that out a bit. So hopefully, we'll be able to see in one visualization both connections. I'm now going to drag on a measure which I've created, which is a simple if statement based on the year, which will show my sales amount as well as my sales amount archive as one measure. And there we go. In a second, we've been able to show a bar chart again with data from both connections. I'll just put on an active indicator here to show how the data comes from each of those. We can expand this out. So our red bars are our data warehouse and the blue bars are our archives. With a well-designed architecture here, we can connect to our Hadoop archive as easily as the relational data sources we are used to. The seamless blending of the archive and data warehouse can help to alleviate strain on the data warehouse while still giving access to our active archive. Okay, so that's that demo. I'm now going to hand over to Claire, who is going to go through the integration of Tableau and R.
Thank you, Maddie, and hello to everybody. My name is Claire Bark. I'm a business intelligence and analytics consultant at Thorogood, and I'll be demonstrating to you today about the integration of Tableau and R. I'll have a quick recap of what R is, so that those who aren't familiar with this technology can have an understanding of its background. So, what is R? R is an open source statistical programming language and environment. Originally, it was developed for higher education, but is now used worldwide due to its analytics capability, which has the potential of driving high value across businesses. R is able to do this by processing and joining complex statistical techniques on small and large sets of data. We shall see a demonstration of this in action later. In future releases of Tableau, we expect to move towards more of these analytical techniques being native to the suite. R can be called enterprise-friendly, as it can be scaled to large production-grade analytical platforms through the use of technologies like Revolution Analytics, which Maddie mentioned earlier on. For the demo today, however, we will be using RServe, which is a local R instance. Now, Let's move on to the integration of Tableau and R. As I just mentioned, R is open source. This means that you can download, modify, and freely distribute R without any licensing costs. Because of this, there is a growing community of users worldwide that are constantly making contributions and changes to R. These changes are in the form of functions, libraries, packages, and saved models. In the demonstration today, we will be focusing on RServe. RServe is a package or instance which enables R to communicate with other software platforms. Other software platforms such as Tableau. The end user is able to see how R interacts with Tableau through the use of table calculations. It's these table calculations in Tableau which send values to R through RServe. R computes the calculations which have been sent through and then sends the results back to Tableau for use in visualizations. Whilst integrating R with Tableau, the complex statistical techniques derived from R can be achieved, while still being able to use the user-friendly environment of Tableau. Many benefits come through utilising the complex statistical techniques in R, for example, advanced forecasting. In the example I will be showing you, we will be focusing on clustering. Clustering is a popular data mining technique that allows you to separate members of your population into different groups based on specific characteristics. This enables you to discover relationships and structures within your data. After the members of the population have been categorized into clusters, it is then possible to identify trends and correlations. For this demonstration, I'd like you to put yourself in the shoes of a retail company analyst, having the objective of better understanding customer segments in order to more effectively target a direct-to-customer marketing campaign. I'll show you how you can build a clustering calculation which connects to R, as well as how you can interact with these clusters in Tableau to gain insight into your data. So I will now share my Tableau desktop so you can see an example in action. This is Tableau desktop, as shown earlier with Buddy. It is a local version where you can connect to data and create reports. I've already downloaded, installed and activated my RServe instance. This is where Thorogood can help. By setting up the connection, we can help you to take advantage of the integration and its benefits. I'll be using a Superstore sample dataset, which you can see here in the top left-hand corner. I've also created a calculated field called clusters. I'll open up this calculation so we can see how it is made up. It is formed from 5 different arguments, as you can see here. These arguments are made from the independent variables, the number of orders a customer has placed, the days since their last order, the number of months a customer has been with us, the average income, and their age. This passes through to R for use in clustering customers. Again, this is where R comes into use, and we are able to help set up R and the script needed in order to implement calculations such as this. I'll now close this window so we can use this calculation in a visualization. To begin, I'll create a simple profit and sales analysis so we can get a better graphical interpretation on how clustering works. So I'll take my sales field and put this onto columns, and my profit and put this onto rows. Now, as you can see, Tableau has already aggregated the data points so that there is only one single data point that we can see. However, I would like to see each individual data point, so I'll go to the Analysis tab and disaggregate the measures. Now we are able to see each individual data point. Each point represents a different customer. I'll now use my clusters calculation, which we saw earlier, and put this onto our colours marks card. We are now able to see how each cluster is split. Cluster 1 is shown by blue, cluster 2 by orange, cluster 3 by green, and cluster 4 by red. We can also add on trend lines to gain more insight into our data. We can now see the correlation more clearly. For example, we can see that our fourth cluster yields a higher profit margin in purchases made by those customers in comparison to all the other clusters. We can see that this visualization does not give us detail on individual customers. So this is what I'd now like to do. I'll create a customer analysis. So I'll start again by taking my sales field and putting this onto columns. But this time, I'd like to take my customer names and put this onto rows. Now at the moment, we can see that this is ordered alphabetically. However, I'd like to see my clusters in order of sales. So I will sort descending, and now we can see that our top customers are in the top part of our visualization. I will now take my clusters calculation that we used previously and put this onto our colours marks card. I'd like to highlight to everybody just how quickly we were able to create this view. The calculations have been made in R, but the visualization has been created in Tableau. One thing you may notice is that most of our top customers are in the first cluster. By keeping this in mind, we will now analyse our clusters in more detail using the measures in our clusters calculation. So I'll head over to my next tab where we can see some box and whisker plots. A box and whisker plot is a simple way of representing statistical data. The middle line in the rectangle represents the median average. The left-hand side of the rectangle represents the lower quartile, and the right-hand side the upper quartile. We can also see our minimum and maximum values, along with our data points and any outliers. I'll just guide you through this visualization so you can get an understanding of the data. On our rows, we have our clusters, and on the columns, we have the measures that were in our clusters calculation. The reason for choosing a box and whisker plot is for how useful it is for providing information on distributions, such as the lower and upper quartiles. We can clearly notice points of information, such as in cluster 3, this holds most of our newest customers. After seeing that most of our top customers are in cluster 1 from our previous visualization, we shall analyse this in more detail. For example, if we look at our days since the last order, we can see that cluster 1 has a much higher average than all other clusters. We can also see that our lower quartile is higher than our upper quartile in our other clusters. Now this could be quite concerning, as it may mean that our customers are losing interest. I will now annotate this by right-clicking, going to annotate an area, so that we can make a note. And we can come back to this later. I would now like to create a comparison between clusters, so I will take cluster 1 and cluster 2. If we look at the number of months a customer has been with us, we can see that these distributions are similar. The median and upper quartile values are the same. So I'll now annotate this again, so that we can make a note. If we look at another measure and compare the clusters, we can compare the distributions again. If we look at the day since the last order, cluster 2 has a much smaller average than cluster 1. If we move over to our number of orders, we can see that these distributions are different again. For cluster 2, the number of orders has a higher average. So I will make a note of this. So so that Cluster 1 has a smaller average for the number of orders placed. Now we have covered several different analysis points. If you look back at our annotations, we can put this into a conclusion. We can see here that the day since the last order, Cluster 1 has a higher average, and this could be quite concerning. For the number of orders, Cluster 1 has a smaller average, which again could be quite worrying. Considering that the number of months these customers have been with us is very similar, this conclusion could mean that our customers are losing interest in Cluster 1. This may mean that we want to start a marketing campaign to win back the business of these customers. It could also create the question whether the purchases made by customers in Cluster 1 are simply higher priced items over a longer period of time. We could investigate this further by creating a report including fields such as product categories. We can see that this one report has brought out several different analysis points, and this emphasises the value of using R as a tool in analytics. It creates many questions that you may not have otherwise asked. With the statistical methods demonstrated, we have been able to identify trends and correlations. The integration between R and Tableau allows us to make use of statistical techniques and be able to produce clear visualizations in the drag and drop interface of Tableau. This combination can be extremely valuable. It means we can create insights into the data, which could lead on to a better marketing strategy through better understanding the customer base. If you are interested in the capabilities between R and Tableau, we can help you. Establishing the connection and creating the steps needed to take advantage of the statistical and analytical capabilities could bring great value to your business, and this is where Thorogood can step in. I will now pass back to Maddie, and she will show you about the integration of Tableau Server and SharePoint.
Thank you very much, Claire. So, yes, as Claire said, we're now going to look at the Tableau Server integration with Microsoft SharePoint. Microsoft SharePoint is a feature-rich web portal technology from Microsoft. It has close integration with Microsoft Office toolset and a similar look and feel that most business users will feel comfortable with. Some of the capabilities that define Microsoft SharePoint are collaboration via team sites and wikis, content management and search functionality, embedded business intelligence through dashboards, reports and Excel, and third-party integration with products like Tableau Server. And this is what we will be covering today. Integrating Tableau and SharePoint allows you to leverage your existing SharePoint deployment whilst integrating Tableau content via Tableau Server. This provides a one-stop shop for your business users. Rather than directing users to a separate portal for Tableau Server, SharePoint can be defined as your single repository for business information. This integration can be achieved with out-of-the-box SharePoint web parts or via Tableau's JavaScript API for greater customization, and this will depend on your business needs. Integrating Tableau with Microsoft SharePoint brings Tableau's robust capabilities into a familiar environment with additional content such as documents or wikis right at your fingertips. All the while, you retain the native functionality of Tableau Server to interact with your dashboards, such as filtering and sorting. For advanced customization, you can use the JavaScript API to define a unique user experience, whether that be for the aesthetic, functionality, or for performance. Our customers are often looking for ways to centralize and simplify access to business intelligence solutions to provide a single version of the truth across large global organizations. Following this approach, we can incorporate our Tableau dashboards into SharePoint to deliver a one-stop shop for BI. We can easily integrate Tableau dashboards into team sites for centralized access, but we can also display them alongside SharePoint content, such as document libraries and discussion boards. Further to this, we can enhance the user experience with custom development. We can maximize our viewing area for visualizations, create unique quick filters not found in Tableau today, and we can even have these quick filters applied beyond Tableau to integrate with other BI tools. So now let's take a look at a Tableau dashboard deployed alongside SharePoint content. So I'm going to share Google Chrome, so you can access Tableau Server from any web browser or from a tablet through the Tableau app. So as we said before, in terms of the Tableau product suite, this is the area where you will share content within your organisation. So in this demo, we're going to take a look at Tableau Server. For those of you who aren't familiar with it yet, we're then going to look at embedding dashboards within SharePoint and then that customized JavaScript API. So the functionality that we have in Tableau Server is very robust, and we find in general that this technology suits most business needs. We simply want to turn to SharePoint in some situations where we need a greater degree of customization. So let's take a look at some of the features of Tableau Server. On the left of the content pane, you will see you can access the other projects, workbooks, views and dashboards that you have access to on the server. And at the top, you can change the content view. So you can view the views and workbooks as a list. I personally prefer the thumbnails, which gives you a bit of a snapshot of what you're going to see when you click on the dashboard. Here you can also download workbooks to access in Tableau Desktop or offline with the free tool Tableau Reader. And we're going to access this dashboard by clicking on the view. This particular dashboard shows the sales performance of our regions against product categories and product subcategories. A few insights as we open this up. We have a lot of green down here for the south in technology, which represents good performance against last year. And up in the west for furniture, we have a lot of red, so very poor performance in terms of sales compared to last year. Also, we have very low sales for office supplies in comparison to furniture and technology. So I'm actually going to exclude this data from the view so we can focus on those higher selling categories. We may then want to sort the data. For example, if we wanted to see which subcategory is selling best in the west for furniture, which is tables. We can then see what data underlies that particular data point. So here we've got a summary of the numbers which make up that particular bar. But we also can see the underlying data, which shows each individual data point which contributes to that particular bar. You may find that as you move to visual analytics, that some business users may find it hard to make the shift from spreadsheets and exact numbers to viewing overviews and trends. The View Underlying Data feature is fantastic in this situation, as users can use the visualizations to hone in on the data they need, but can also get the detailed cross-table they are used to, which can be exported to Excel or a text file. Other options we have here, we can download the workbook again. Clicking on Remember My Changes allows you to save a custom view to come back to later, so I don't have to apply all of those filters again. And finally, we can revert the view to remove all of those filters. That's a quick look at Tableau Server. Now let's take a look at how we can embed this dashboard into SharePoint. As you can see here, we are simply using a page viewer web part to view exactly the same view on Tableau Server exposed within SharePoint. I'm going to click here on Focus on the Content so we can see this dashboard more clearly. We don't have too much, we've got quite a lot of white space around the dashboard, so we can get rid of that and see the data more clearly. As well as the Tableau dashboard here, we also have relevant material which is stored within SharePoint, which is relevant to the Tableau dashboard. Here we have a notice board which will allow users to comment on the insights from the dashboard and discuss how to follow up on this insight. We also showed a document library containing any supporting documents used for investigating any issues, tracking any changes or explaining what might be happening. So here we've got some targets information and organisational charts. You can add commentary into Tableau Server. However, what we've created here is a much more robust and integrated solution. It means you don't need to manage commentary in two separate portals. You may be wondering now if we can interact in the same way with these dashboards when using them in SharePoint as opposed to Tableau Server, and the answer is yes. All functionality from the server is available in the embedded view. So just to show you some of that functionality, let's filter out office supplies. We can sort on data in the West, and even view our underlying data, just as we could on the server. We can bookmark changes and revert the view. So all of the same options as we had before. You can customize these options so you're able to pick and choose which Tableau server features are made available to the user within SharePoint. Finally, let's take a look at the functionality available using Tableau's JavaScript API. My final link here. So this is highly customized functionality and not available out of the box. So we would recommend bringing in a company like Thorogood to set up content like this on your SharePoint deployment, as it involves a large amount of customization. The API provides a tremendous range of interactivity, not only in the Tableau view, but also over the rest of the web page. When I access this dashboard, we have set this up so that we have to log in to access the data. For instance, type in my password. We could also set this up so that we log in automatically, as in the previous example. In the most recent version of Tableau, in 8.3, we can enable Kerberos integration, allowing Windows authentication, which wasn't available in previous versions and has been a very popular update. So you may have seen, as my view opened, that we have set the view up to automatically filter on the year 2012, so a slight filter on the data as that opened. One thing that might be quite obvious here is the lack of quick filters if you are used to Tableau dashboards. This means we have plenty of space for visualizations and to explore the data. In general, we usually find that users want lots of quick filters on the dashboard in order to control the view of their data. This gives lots of options for interaction and exploration of the data, but can affect the space on the dashboard, the tidiness, and also the performance. In this example, however, we haven't given up our quick filters. We have just hidden them in this custom filter area to save space on the dashboard and also for other supporting content within SharePoint, similar to what we saw before. By expanding the custom filters area, we can see several filters which are very similar to those which we would create in Tableau. So by doing this, we haven't given up any functionality that we would normally use. We are simply enhancing it. Here we have the range of years, and we're going to focus in on the West region, which is what we were looking at in the previous example. You will notice that as I've been changing these filters, the dashboard is not updating. This can be a huge help in terms of the performance of your dashboard if you need to set several filters every time you view the data. The standard Tableau filters have to be applied one at a time, meaning a new query will have to be sent to the data source for each filter you change, and this can become quite a slow process. In this case, we've set our filters, and if I click Apply, all of those filters will be applied at the same time, meaning that we only have to wait for the data to reload once. We do have one filter still here on the dashboard, this top product filter, so it's just going to change the number of products we're viewing. And this is still available alongside the JavaScript API, so we can use both in conjunction. Another very popular feature with this custom functionality is the enhanced hierarchy filters. So if I go to products here, you'll be able to see this hierarchy. We often see a lot of frustration with the options for hierarchy filters on a relational database. In the current version, you will need a separate filter for each of these levels of the hierarchy. In this situation, I'm going to focus on furniture in the West again, as we did before. The API hierarchy filter we have created here is very user-friendly, allowing us to expand individual branches of the hierarchy and even giving the ability to search. So we can type in furniture. As before, no values will change in this view until we click Apply. The customization gives a much more user-friendly and succinct view for the filter than would otherwise be available. Okay, so that's our API filter. Now let's go back to the slides for a quick wrap-up. To recap today's webcast, we hope you have a better understanding as to how Tableau can integrate with other technologies like Hadoop, R, and Microsoft SharePoint. If you have any questions, or if you would find a deeper dive on these topics to be valuable, then please reach out to us. We will be providing our contact details via the chat pane. For anyone on the line that is newer to Tableau and would also like to see more introductory material, let us know and we'll be happy to share this as well. If you're in need of Tableau expertise, we'd be happy to discuss how we can help. As a strategic alliance partner of Tableau software, we have exceptional credentials with Tableau in the enterprise. We can help you get started with Tableau, perhaps with a proof of concept, evaluating how Tableau would fit within your existing BI architecture. We can implement Tableau solutions or troubleshoot solutions, particularly when it comes to performance, which we find comes up a lot with our customers. We also provide Tableau training. If you head to the Insights link below, you can get some more videos for the material that we've covered today, so integrating Hadoop, Tableau with R, and that one-stop shop for BI that we were looking at with SharePoint. And lastly, here is a schedule of our upcoming events. You can register for these events on our website, which is listed here. So we've got a few more webcasts coming up, and if you are based in London, we will have some workshops and seminars. Thank you very much to everyone on the phone for joining us today. It looks like we're just about out of time, so we've been capturing all of your questions from the chat pane. And of course, if you do have any more, then please do post them on Salesforce Chatter or get in touch with us via email, and we will be happy to answer those for you. And for those of you who haven't asked questions or be interested to know some more information, we will also post those questions on Salesforce Chatter along with a video of today's webcast and the slides. Thank you very much.